All right, I think we are good to start. First, welcome everyone to join the ABB TechTalks about lowering energy consumption on board passenger vessels with HVAC solutions. First, couple of practicalities before we go into the presentations. Please do keep your microphones muted all throughout the session. We are recording this webinar and using it for marketing purposes, as well as we'll share the recording to all of the attendees afterwards. There is a Q&A session in the end, and you can type in your questions to the chat all throughout this session. Please note, we're also organizing a couple of polls in all of the three sections of this session today. So you can see them on your right-hand side, and please do answer. Today's presenters, we have Frank Grundholm from ABB Motion. Hi, Frank.
Jana, thank you very much for today.
Thank you. Thanks for joining us. And then we have Bart Können from Architect. Hi, Bart.
Hello, Jana.
Hi. And then Antonis Asimakopoulos from ABB Marine Ports. Hey, Antonis.
Hello, Jana. Hello.
Hi. Good to have all you joining us. Thank you so much. And with this, we'll start with Frank.
Thank you very much, Jana. So my name is Frank Grundholm. I'm the Global Vice President of Sales for our HVACR, in the ABB Motion division. ABB Motion covers the motors, drives, and PLC portfolio of ABB. I'll talk a little bit today about why we need to focus on the HVAC installations in the marine area, a little bit about the industry requirements, and maybe what is really relevant and what is maybe something where we need to look at doing some things differently. Talk about the motion solutions that we have in the industry for the industry, and then also at the end I'll share my contact details. As was mentioned, the poll is on your right-hand side, so if you take an opportunity to just answer those three simple questions and send them in to us, then we'd really appreciate that very much. So first of all, what are the purposes of the HVAC systems? Of course, it's first of all to secure the air quality on board the ship during the normal operation. But it has a secondary function as well, which is to protect the passengers in the event of abnormalities. That can be fire. It can also be, as we saw with the pandemic, a need for isolating certain parts of the ship from other parts of the ship to prevent the spread of virus. Important aspects include the comfort, of course. It includes the energy efficiency as well of the systems, but also the reliability and safety of the entire operation. When we look at the energy consumption on board, it has essentially three main parts. It's the HVAC systems, which are about 30% of the entire energy usage on a cruise ship. Then it's the propulsion, which is another 30%, and then there is the rest of the operations on board, which takes up the last third of the energy consumption on board a ship. So clearly, I mean, yes, propulsion is important, and we need to optimize propulsion of the ship to reduce the energy that's consumed by a ship, and thereby also the pollution that a ship causes, since a lot of the ships today still have to be powered with fossil fuels. So the only option we have to make operation more sustainable is to reduce the energy consumption. But HVAC is as big a part of the total energy use, and that's one of the reasons why we really need to look at optimizing the usage of energy in that area. So when we look at these 30% and look at what are the simpler options that we have, well, the first and most significant saving we can get is really by applying variable speed drives. Variable speed drives applied to pumps and fans can save up to 60% of energy by running the motors at the speeds required to produce the air flows or water flows needed in the system, compared to using a valve or a damper, which is essentially the same as if you run the motor at full speed and you throttle with the valve. It's like putting the brakes on and keeping the full speed on your engine in the car. Nobody drives a car like that. Why should our pumps and fans be run like that? So let's try and leverage that energy. At the same time, legislation has driven a lot of development and engineering around motor technology. With the new motor technologies, we've gone from the previous IE1 level, which is still installed on many ships, and today we're all the way at IE5. We have an opportunity to reduce the losses in our electrical motors by up to 40%. Again, saving substantial energy on our operations in the ship and thereby saving on the fuel charges that we have for the ships. Those are the simple ones. Then when it becomes a little more complex, we need to look at gathering enough data about how the different parts of the ship are loaded, looking at how can we optimize temperatures in different ways around the ship, optimizing air quality around the ship depending on the occupancy of different sections of the ship. All of that intelligence we can put together in cloud-based solutions and really further optimize the total savings that we have on board. And this intelligence in itself can provide a 30% energy saving. Now, I'm not saying it's 60 plus 40 plus 30, so 130% saving. That would be great, but that's not the case, of course. It's incremental savings of each of these parts. So if we take a look at the passenger cabins, of course, one of the primary concerns around the cabins is the comfort of the passengers. Passengers that take a cruise and feel uncomfortable in the cabins are less inclined to take another trip later. So it's bad for business to have poor comfort in the rooms, and air quality is a significant driver for the comfort of passengers. So we need to capture temperature, humidity, and CO2 levels in the cabins with sensors and feed that either to the drives and then provide decentral controls with the drives, or to a control system that can then manage the applications. So really the comfort, but humidity is also a significant impact on the health on board. So managing humidity in the right way is essential also for the health of the passengers. And we need to meet the control needs, the flow and for heating and cooling in the coils, so that we manage the humidification of the cabins. While doing that, the other aspect, which is often forgotten, is actually noise. One of the things that annoys me the most is when I come into a room and there's a fan running somewhere in that sends noise through the ductwork, and I can hear it in the room. I can hear that constant humming of the fan. By applying variable speed, you can reduce the speed of the fan, and the speed and noise ratio is a logarithmic function. So by a small reduction in speed, you get a significant reduction in the perceived acoustic pressure that you have from the fan. And the third aspect we have to take into consideration, of course, is that when we talk marine HVAC, we're actually not talking about a standard environment. It is still an environment where we have salt. It is still an environment where we have small confined spaces, and the risks when we have someone who's sick, for instance, is higher, that whatever the person has is spreading. So we need to be able to manage also the cabins in a way so that we can use them for isolation of passengers. There's been a lot of talk about the sizing and reduction of sizing, and that's put some focus onto the EC fan side of the business. But EC fans have the disadvantage that they're single purpose. They can only be used for the normal ventilation. So if you've got combined systems that also require smoke extract, they cannot be certified for that purpose, because the electronics internal to the fan wheel simply can't withstand the temperature requirements. In addition, very few of these are available with a sufficient coating, which means that the risk of corrosion is also higher. When we talk about combined use, or even dual installations where you have one for ventilation and one for smoke extract. The important part is that when there is a fire situation, we have to make sure that the units run as long as there are passengers in harm's way, or as long as the fire brigade needs access, or the crew needs access to an area. Because we need to remove the smoke out of the affected areas, because it's the smoke that kills. So the ventilation is crucial for managing emergencies when it comes to fire situations. With the drives, we have a fireman's override function that actually secures that no matter what happens, the drive will prioritize running the fan before protecting itself. Under normal operation, if the ambient becomes too hot, the drive might reduce the speed of the fan. It might even shut down entirely, simply to avoid that you have a component failure. But in a fire situation, it's life and death. And then the equipment can be set with a simple switch or the signal from a controls that you have to prioritize the operation over the protection of the components. Looking at the specific requirements on board a ship, we all know that when you're on a ship, there can be a lot more vibration than you will see in most land-based installations. But at the same time, when we talk about cruise ships in particular, there's a big difference between below deck and above deck. Below deck, you have the engine rooms where you will have a lot more vibration, and there's a higher risk that you impact negatively the safe operation of the ship as well if you have failures. Here, of course, very stringent requirements are necessary. If we go above deck, first of all, vibration has already been managed because we are considering the comfort of the passengers as well. And no one wants to be on a ship that vibrates all the time. You simply go crazy. So the risk also for equipment above deck is a lot less when it comes to vibration. So we can differentiate in the requirements, and with that we can also optimize the cost of our ships. We need still to manage, of course, the high humidity situations, because depending on where the ship is sailing, the humidity can be very different. The hot and cold as well depends on the ambient of the ship and will impact the operation, as well as salt mist. To manage all of these different climate challenges, we're able to provide both coated circuit boards, high IP variants, and we can even provide something called flange mounting. It sounds technical, but what it really is typically you would install your drives in a box, but drives produce a lot of heat. When you confine heat inside a box, you need to cool the box to avoid overheating. Flange mounting essentially removes 80% of the heating through the back side of the panel without heating the panel. Now you can reduce the cooling requirement and thereby also reducing the fuel consumption for cooling of the equipment on board. And that also helps expand the operating temperature, allowing you to have more variance. When you apply drives, the one negative that you really need to look at carefully is the power quality. Any variable speed product will provide some level of electrical noise. And it's important to specify the acceptable levels in order to avoid operational issues. Excessive harmonics can really decrease the system reliability and impact also the energy efficiency, because they cause heating in the entire electrical system. This is one of the reasons why the classification companies have requirements for the voltage distortion. And that is for typically 5%, but for Lloyd's it's about 8%. Those are the normal requirements, but you need to have a system simulation of the entire ship to understand whether you're over or below the required levels. What we have done is we've developed solutions with active front-end technology that actually reduces the current harmonics, which is the electrical noise on the current level, to 3%, and that the current is actually what drives the voltage distortion. When you only have 3% current distortion, your voltage distortion is close to zero. So by applying this, especially on the bigger loads, You avoid any risk of exceeding the classification company's requirements and thereby also avoid the requirements for installing additional filtering. When you don't have to install additional filtering, you also save space that can be used for other purposes. So you avoid the negative impacts on your network quality, you avoid impact on your UPSs, you get a higher efficiency because you don't have the heat losses on board, and heat losses come from the electrical power generated but not used in the application. So that means that you're using fuel to generate heat in a place where you don't need heat. And that, of course, means that your fuel consumption is higher than it needs to be unless you reduce the harmonics. And therefore, also, good harmonic mitigation is actually a more sustainable way of managing your cost on board, both operation and also from an investment point of view. If we look at the real impacts, then cable sizing, whether you've got 10% current distortion or you've got 50% current distortion, the difference in sizing is about 10%. Now, this, of course, means that you can reduce your cable sizing by 10%. It also means that you're reducing the heating generated by the harmonics. But additionally, and more importantly, maybe for some, you're also reducing the weight of the cabling on the ship. That means that your entire ship cabling suddenly gets 10% lighter, which means you need less fuels for the propulsion. Same goes for transformers. It's a 20% size reduction. And for your generators, it's actually almost 50% size down. Not because of the heating, but because standard drive technology has a negative impact on the voltage regulators in the generators. And therefore, active front-end drives are preferable because that allows you to use smaller generators and load them more fully, and thereby leveraging your investment in the generation more effectively. So really compacting your installation by not having to have a lot of external components, securing a wider temperature range because you can remove heat from your installations, and also reducing the sizing of your installation simply because your cables, fuses, switch gears, transformers, it can all become a little bit smaller. Now, when we look at digital services, drives have been digital for many years. You've been able to connect to serial communications. You get warnings, alarms, conditions, temperatures inside the drive. There's a lot of information that we've provided for many years. We've gone one step further now and developed sensors that can actually be connected to electromechanical and fully mechanical components as well and help provide data on the condition of those. First, we started with the motor sensors where we monitor the bearings, the stator, widening conditions based on temperature, vibration, and acoustics. And then we have expanded that gradually through the bearings. And so when you have external bearings, we have sensors for that. And even gone out and had a collaboration with some pump manufacturers where they use our sensor technology on their mechanical equipment to provide updated information on cavitation issues, balance issues on the rotors, and that way you suddenly have a full drivetrain where you can really get a lot of predictive information that can help you avoid operational issues. Just quickly on the portfolio, it's the variable speed drives in a full range up to 6 megawatts. Electrical motors also available for a harsh environment up to 2 megawatts, and a full range of PLCs, both for standard operation but also for safe operation. So the safe PLC functionality with safe communication is fully available in that range as well. Any questions and comments you have, feel free to email me. My email is right here, and also feel free to connect with me on LinkedIn. I'm happy to engage in any dialogues that you might find relevant for a further dialogue with us. And with that, Jana, that was the end of my presentation.
Super, thank you. Now let's move over to Bart.
And I need to turn on my speaker, then I can hear what you're actually saying. Sorry.
Hello.
Hi.
Good afternoon. Jana, is it good now, the sound?
It's very good, thank you.
Okay, thank you. So, good afternoon all. My name is Bart Kunnen. I'm the director of Architect. Architect is a company focusing on the marine industry and on HVAC and is a partner of ABB. And I would like to talk to you about the ABB Architect RM20 solution, which we developed the last 4 or 5 years together with ABB. It's a retrofit solution, a software solution. We install it on vessels, industrial computer connecting to the existing system. As said, it's a retrofit solution and it's quite easy to install. And the main focus of our system is, of course, saving energy with the system. I want to say, okay, on the right side, you see some questions. So please take a look at those questions and answer those, because for us, it's very interesting to hear your opinion on this. So going back to my story, so our first goal is to save energy. Secondly, to improve and monitor the internal air quality, collecting data, supporting the operational staff on board the vessel and the management ashore with the dashboard. We're saving a lot of energy. And on a cruise vessel, it's at least 100 to 150K per year. We guarantee that. And on ferries, it's about 40 to 60K per year. And I'm not going to tell about, let's say, the percentage of HVAC consumption on a vessel, but what I can say is that from the total HVAC consumption, our system can save up to 20%. If you look at our system, in general, it's a retrofit solution looking at vessels, let's say for 20 years old maximum, 20, 25 years old maximum, up to vessels that are fully new. And if you go back to old vessels, they are manual operated and or semi-manual operated. And our system enables to continuously optimize set points of chillers. We look at night and day situation, port navigation, empty or full, how full the vessel is, humidity, that kind of variables we are looking at. And taking a closer look at our system. So our system is installed and we take a holistic view at the whole HVAC system. So we're looking at the chillers as a starting point, the chilled water, the chillers, but we're taking a look as well, of course, at the air handling units, fan coil units, and all systems within the HVAC environment. That's one side. The other side, we take a look at the demand comfort in cabins, restaurants, etc. And we guarantee that we deliver that comfort. So we're not. It's very easy to save energy to put temperatures up, but we're not doing that. So we're looking what's demand and we deliver that. But we come back on that later. The whole idea behind is that we see that an HVAC setup on a cruise vessel is, let's say, 90% of the time over-dimensioned because it's set up for an environment where it's very hot, very humid, and 90% of the time that's not the case. So if you can look at your set points then and optimize them, you can save a lot of energy. Of course, how can we save energy is one very important part of our system is that we look at the set points of the chillers, and if we increase the set point, for example, with 1, that means that the compressor motor is using less energy, and that's per degree. It's at 3 to 4%. So that can run up quite a bit. And in a port situation, that can mean that we can reduce the energy consumption up to 30%. And again, what I said, that we don't change the indoor temperature. If you look at the system, what we do, our industrial computer is put on the vessel. It's connected to the existing HVAC control system, and we can connect to all kinds of systems. That's not a problem. So we take the data from the HVAC control system and said we're connecting to the chillers where we can change the set points. Our system is connected with the cloud, but it can work as well standalone. But if we connect to the cloud, we can what we can do then is that we can, with our system ashore, we can add some extra data, for example, about temperatures or temperatures that will come up during the journey. So we can make the system on board smarter. That's one part of our system. What we also do is with the data we get from the vessel, we can supply the management ashore with a dashboard where they can have a look at the vessel, how it's performing. Also, we can provide energy reports, and we can look at KPIs which we agreed with the vessel. So if we come above certain KPIs, that we can act on that and give remote support or give an alert. So that's an important part of the system as well. So if we take a closer look at what on board of the vessel, what the operational staff can see and do with our system. So this is the main dashboard, and what the crew on board can see is if our system is on, and if we are optimizing the chillers. They can see historical data. They can see how much we saved on the energy side. So in this first main dashboard, they can have a full overview of the system and simply see how it's performing. They can dig into this into the HVAC system by, for example, going to the chiller page, where they can have a look at the current values of each chiller. So you can change from one chiller to the other chiller. You can see all kind of info, the chilled water temperature, the actual load, set points, what I said, key performance indicators. So here you can see what's happening with the chiller. As well, we have a separate page for the air handling units. And again, you can switch from each air handling unit to another air handling unit. And here as well, you can see the current values of each air handling unit. And from this, you can dig into what's happening there. So it makes your life much more easier. If we go to the next page, that's the energy page. And here you can see historical data from what's happened with the energy consumption. You can look at what your targets are with energy consumption and where are you now. You can do some benchmarking, for example, between certain chillers or handling units. So you can compare what you want here. It's flexible. As well, from this point, you can download your data to other areas where you can do other things with the data. So, but in fact, a lot of is built in our system and fixed so that for yourself, board of the vessel, it's very simple to look at historical data. If you look at the main features of our RCM20 system, system analytics, that's one thing. Of course, energy saving, which is the third block. That's of course the most important item. But system analytics, remote support, energy saving, and of course, we can customize what the customer wants regarding cyber security, regarding dashboards, regarding data which you want to extract, regarding KPIs which you want to have, and of course training specific for a vessel, for a crew. Also important to mention regarding energy saving is the very short payback time. Again, on the right side you see some questions, so I'm very interested in what you think should be the payback time. So let's have a look at some extra features. With our system, you can get a lot of data which you can use to have a better look at your internal air quality. You can have a look at the performance of your air handling units, which, if it's not performing well, which has a direct impact on your internal air quality. What we also can do is install some extra sensors. If some items are not measured on the vessels, we can add on some sensors, plug them into our system, and directly you can see what's happening related to, for example, CO2, to particulates, etc. Predictive maintenance, that's clear, because you can compare how air handling units are working, chillers are working, so you can act on that. And last but not least, if you look at our system, what it can mean for a vessel when entering into the port, reducing energy consumption, reducing emissions is getting more and more important there. And together with the crew, we can look at how we can reduce the energy consumption of the HVAC system. Of course, our system is doing it automatically, but what can we do more? Also, what we can do is, if the vessel is looking for to install battery facilities to work with shore power solutions, that we can how we can reduce the energy consumption of the HVAC so that the investment in a battery solution or a shore power solution is less. Summarize. Our system is a retrofit solution. It's easy to install. It's optimizing the HVAC system, analyzing data. It's a proven technology with guaranteed energy savings, short payback time. With our system, you can improve your internal air quality, and it's helping the crew in the daily operation of their HVAC system. So that's it from my side. Here you see my contact details. So if you have questions, please let me know. And we are very interested to look at opportunities or problems you occur. So let us know. That's it from my side.
Great, thank you so much, Bart. Now let's move over to Antonis.
Yes, thank you, Jana. So good afternoon from my side. Good morning. My name is Antonis Asimakopoulos, and I'm responsible in ABB for performance monitoring and energy efficiency portfolio. Today we are going to discuss about engine room ventilation fans VFDs upgrade. Let's see a little bit the agenda. A small update on the portfolio that ABB offers, a part of the portfolio, more accurately, that ABB offers to marine customers. We will answer if energy efficiency matters. We will check some marine classification rules, the annual mean air surface temperature, the relationship between speed power for fan systems, the current flow control methods for fans. We will see how a variable frequency drive looks like, and we are going to analyze how ABB is implementing the ventilation system. Some system photos, some energy saving analysis, and for the end, the system features. So performance monitoring and energy efficiency is belonging to digital services business line in ABB. Let's start with the performance monitoring. ABB has solution for fuel monitoring, Coriolis mass flow meters, shaft torque meters, electric power meters, SEMS analyzers for scrubbers, electromagnetic flow meters for ballast water treatment systems, and also a system called SealMate for 24/7 pressure monitoring. Today, as mentioned before, we are going to discuss for VFDs for fans. Nevertheless, the application can also help with pumps. Also, winch control, HVAC solutions we mentioned before, and DEGO 4, our anti-roll governor for main engines. So, the big question, does energy efficiency matters in shipping? We have seen the last year that the oil prices have dropped significantly. And the question arises if it is really important to reduce the efficiency. And the answer is for sure yes. Let's see a couple of reasons. So first of all, with reducing the energy consumption among motors on board the vessel, you can achieve maybe to turn off a second or third generator. This can result in much more less fuel and maintenance needed for the generators. Also, the increased needs of ballast water treatment systems or scrubbers, the increased need for power can be handled with energy efficiency devices such as drives. We can achieve lower emissions, CO2 emissions, and of course we can comply with regulations coming, EEXI, as you all know, from 1st of January 2023. It is mandatory for practically all over the vessels around the world to reduce their emissions and comply with EEXI. On your right hand side, you will see also a couple of questions. It will be very nice if you can answer to those questions. Few things about marine classification rules. In general, in the design phase of a vessel, we consider the air temperature around 35 degrees, the engine room maximum air temperature at 45 degrees, and the engine room overpressure at 50 Pascal. Also, we consider full speed on main engine and auxiliary equipment. Let's see a little bit the mean air temperature around the world. As you will see, we don't have a constant temperature. It can vary from 0 degrees to 30 plus degrees around the world. So it depends on where the vessel is operating. Regarding speed and power for fan systems, the affinity laws apply. For flow, head and power. All in all, we can see that with a very small speed reduction in a fan or a pump of around 10%, we can achieve 25% reduction in the power of this fan, which is quite important. The current flow control methods for fans exist of fan dampers, fan overflow valves, fans with adjustable blades, with inlet guide blades, in some cases only motor on-off control. Of course, on all of these cases you control the flow, but unfortunately you don't have any major energy reduction on the electric motor. This is how a variable frequency drive looks like. Variable frequency drive is a type of adjustable speed drive used in electromechanical drive systems in order to control an AC motor speed and torque, and this is achieved by varying motor input frequency and voltage. This is a small example of how a drive looks like internally, the electrical drawing. So let's see how the engine room fans ventilation systems are today, more or less. So there's no measurement of air temperature or differential pressure. Usually we have manual on-off control of the motors. So as I said before, there is no major energy reduction on the electric motor, and we don't have any speed control of the motor. This means that we may have more than 50% unnecessary fuel consumption for the operation of the fans. How we do it in ABB control systems? We measure average main air temperature inside the engine room, and at the same time we measure the differential air pressure between engine room and outside deck area. With the temperature, we control the motor lowest speed, so this is a set point for the lowest speed, and with the differential pressure, we control the speed of the motor up or down, depending on what is the measurement for the differential from the differential air pressure. In this way, we have an optimized airflow and fuel savings for the motors of more than 50%. Here you can see some system photos from the cabinets. This cabinet is a two-door cabinet in most of the cases. Behind each door we have a drive. Each drive is equipped with a manual bypass switch. This means that in a case of emergency, or if something happens with the drive, you can easily bypass the drive. You have also some indications for the system status with LED lights, green or red accordingly. There is also a small touchscreen that can be located either in front of the cabinets or in the ECR. Here you see the air temperature sensor, how it looks like inside the engine room, and also the differential pressure transmitter, which is the one end is located inside the engine room and the other end outside. Here is how the touch panel looks like. From the touch panel, we can get information about the status of the system, how many hours the motors are working, what is the speed of the fans, what are the set points for the pressure and the temperature, what are the savings, etc. Here is a typical energy savings monthly analysis in an Excel format. The touch panel has the ability to export in an Excel format this analysis every month. So you can see it split per month, and you can see in the first column the direct online consumption, meaning the consumption without the drive, the consumption with the drive, the difference, and also the energy saved percentage-wise. As you will notice in this column, the savings in the majority of the cases are more than 50–60%. Some system features. The system has fail-safe functions. It can work either forward or reverse for the fans. We can have a soft motor start and stop, bypass function. For the pumps, if this is applied to pumps, we have anti-jump or backflash operation. We can very easily communicate with third-party systems, export energy savings reporting, alarm events, the touch panel I mentioned before, email reporting, and we can also access the touch panel from the office if needed. Okay, let's see some more. The energy savings can reach up to 80% for fans, but also for pump applications. The payback is usually less than 1 year. And you have also some features for the pumps that you can see here. For example, three-way valve control. There's no need for the valve control. You don't have cavitation. The cabinet in both fans or pumps applications is maintenance friendly. We have a standardized and compact cabinet design. All the components, the major, are marine certified by all major classification societies. And the major benefit is that you can have our support globally, since ABB has service stations around in more than 100 countries. Again, all the major components are manufactured by ABB, and you can have one contact point for your system. Thank you very much for your attention. In case you need any information from my side, please feel free to contact me in the email that you see on your screens. Thank you very much.
Thank you, Antonis. I think we could now review all the polling questions and then see the answers. Let's start with the Frank section. So would you, I can read the question and then you can interpret the answers, Frank. So first question was, how often do you see requirements for equipment compliance with increased vibration levels for the upper deck area? Oh, you are muted, Frank.
Sorry about that. I was just asking, are you able to display the results? Because I cannot see the results of the polls.
All right, yes. Let me share it.
All right, there we go.
Yeah.
Now I can see it. Now I just need to make a small screen adjustment here. So I'll actually just take it across all three questions asked. The response is very similar. It's similar to what we saw. We had a similar webinar this morning, and we saw similar responses where it is I'd call it a mixed bag. Some projects have requirements for both the conformal coating for the high vibration, others do not. And my interpretation of this is that it's probably got to do with which shipyards are you working with, which classification companies are you using, and which ship owners are driving what specification. I think it also shows that it's not an issue not to have this always on the above deck equipment, but in many cases it's easier to just have one requirement for the whole ship. It does imply mean also that, however, that it adds more cost maybe to the ship than is necessary. And considering the scale of the HVAC systems as an example, it is something that could be considered in a dialogue with the ship owners. What are the real necessary requirements? And also with the classification companies, yes, vibration is important, but is it important in all parts of the ship? Maybe not necessarily. And thereby optimize the solutions also from a cost perspective without impeding on the functional requirements that the ship, of course, has and that all the units on the ship need to comply with.
Great, thank you. Then we can move over to the questions which were in Bart's section. So Bart, can you see the results?
Yeah, I can see.
Okay.
Yeah, let's first have a look at payback time. And it's you see the most is 2 to 5 years, so that's good. Some 1 to 2 years. So in general, I think that 2 to 5 years should be realistic for energy efficient solutions. Good thing is that the ABB RCAM20 system is up to 2 years, so 1 to 2 years. So that's within line. Then a second question. I cannot see it anymore, Jana. Wait a minute.
Sorry, it is still there. So
yeah,
the question was, is HVAC information more important now compared to the?
Yeah, and I saw the result, and it was that it's more important. So that's also good to see that. And the last question is it more that you are pushed by regulators? That was the most answered option. I think that's how we work all. We of course we look at rules and regulations and we act like that. So I can understand that. So yes, and said that, I think that after answered those questions 3 times in for us a good direction, so they should contact ABB Architect to discuss this. So thank you.
Thank you. Thank you. Then last but not least, let's go over the polls for Antonis before we go into the questions. There are a couple of questions coming, so that is
yes,
good.
Jana. Thank you.
Yes.
So we had 2 questions, one related to EXI, and if our customers think that drives can play an important role in reducing the EXI, the majority answered yes. The truth is that it looks like that VFDs will play a major role. either by using them in large motors, either in systems with shaft generators. In general, power electronics will play an important role in the reduction of EXI in the future, and not only. The second question was related to how, if you are using drives on your ships already. Again, 5 out of 7 replied that yes, and the other they didn't answer something. But I think that if we compare the usage the last years with the usage 20 or 15 years ago, the drives penetration into the marine industry has increased a lot. And personally, I feel that we will see more penetration the next decades as the ships are moving more and more into, let's say, more digital electric vessels. Thank you, Jana.
Thank you. Now a couple of questions. First, for Frank, let me read them through. First one is UL or UUKL smoke control sequence used here? Frank, you're on mute again.
Sorry?
No worries.
I'm not entirely sure what is actually meant by that.
It was coming together with another question called or going, how is it different HVAC system in ships and in commercial buildings?
Well, one of the differences really is that when you're on a land-based installation, it's of course the regulatory framework of the country that applies. But when you're on a ship, the regulatory framework is more determined by the classification companies that actually certify the ships for operation. And therefore the rules and around how you design your equipment and what levels of, for instance, vibration you have to comply with are set by the classification companies. And that means that the ship classification, which typically has higher requirements than land-based installation, will be the ones governing the requirements for the installation as well.
Great, thank you. And another one for you as well, or yeah, continuing to you, Frank. Do you use BMS or BAS systems or PLC controls for HVAC?
It's a little bit of both. When we talk about unit control, we frequently use PLCs or the built-in functionality of the drives to do the internal controls of the air handling units, for instance. But we also have the BMS systems that control between the different apartments or passenger cabins, for instance. Those controls are also part of our offering and are very similar in design and functionality to what you would find, for instance, in a hotel. So ABB offers both solutions. We also have dedicated controllers as part of our BMS offering that are designed also for air handling unit controls. So we have a little bit of every offering. If a customer wants to really program specific functionality, then we would use the PLC. But if they're fine with standardized functionality developed by ABB, then our dedicated controllers would often be the more cost-efficient solution.
Okay, thank you. There was a little bit of clarification to the first question. So UUKL is smoke control sequencing used in commercial buildings. And that was then the question.
Okay, yeah. I mean, more and more the commercial buildings are moving to the IEC 12,000 standard framework. And that sets the rules for certification as a package. That framework and the UUKL framework is not really applied in ships. It is guidelines and rules that are set by the classification companies, and it will be specific between the different classification companies.
Right. Thank you. Next question goes to Bart. Here we go. When you increase set point for chillers, may it affect on other HVAC like air handling units or FCUs? They need to work hard to achieve set points. Do you agree or have any comments here?
Yeah, well, we're looking at both. So we are looking at what's happening with the air handling units as well, because otherwise it's not working. So it's an integrated system. So we're looking at the air handling units and we're looking at the chillers. So otherwise there's no effect. So I agree with the person, but we do manage both.
Okay, good. Then what kind of protocols used, for example, BAC net? Continuing to you, Bart. BACnet, what kind of protocols?
BACnet. Yeah, we use BACnet. So we have different protocols we can use. So it's not like we are restricted to one or another, but BACnet is for us an option. Yeah.
Good. Then Bart, do you use demand control ventilation for air quality?
So, sorry, the question was that how?
Do you use demand control ventilation for air quality?
No, we don't do that. What we do with, let's say, with analyzing the data, we can see how the ventilation, how effective it is. So it's more like analyzing data. So we're not, so we're not interfering in that at all. But with analyzing data or with putting extra sensors on, we can see the effectivity of the ventilation.
Right.
Hopefully that's the answer.
Yeah, thank you. There is one more question to you, Bart. I can see batteries used here, but for demand limiting, we use batteries, so it's less electricity charged at nighttime to charge it. What is the use of batteries here?
We don't use batteries, but what we see is that if you have batteries on board of your vessel and you use batteries to power the HVAC, so with reducing the HVAC consumption in general, you can use your batteries longer. So that's how it affects batteries. So for example, what I said, if you, for example, want to be zero emission in port, you can use shore power, but you can also, some cruise vessels are doing that, add on battery capacity to the power used by HVAC and other systems is delivered by the battery. But we know that in port, the HVAC system is the biggest consumer. So if you limit the consumption of the HVAC system, we do that automatically, but also in good cooperation with the customer, then you can use the battery longer. That's one thing, or you can use smaller batteries. So it's less cost because batteries are very expensive.
Super, thank you so much. So that was it for the questions. So first of all, thank you so much to all of you attendees for joining and asking great questions and answering our polls. Super interesting to get that feedback. And then thank you to the presenters. Nice having you on board. And yeah, with this, let's close the Tech Talk and wish everyone a great evening, afternoon, or day, wherever you are.
Thank you all.
Thanks, Anna. Thank you, everyone, for the questions. Have a good day.
Thank you, Jana. Thank you all.
Thank you.
Thanks. Bye.